discuss these items in more details in the other slides as well, in the other lectures. What we discussed yesterday was why do we collect traffic data, where do we need it, what are the ways in which we can collect data, and now we are looking at different types of studies which we can do to collect traffic data. Okay, and there's a list of studies here. Okay, these are the types of studies which we normally do with the traffic data or for the traffic data. We discussed some of them, and moving forward you can see the video. It's no big issue, it's not connected. If you didn't attend the yesterday's lecture, it's not like you cannot understand these things. So pedestrians, one of the things which I mentioned yesterday was pedestrians are also part of traffic. So traffic is no longer about vehicles. Pedestrians are part of traffic, okay, and they become very important because of their interaction with the vehicles. Okay, when pedestrians and vehicles are at the same point, then it becomes dangerous, right? Okay, and when can they be at the same point? Pedestrian vehicles, when they come at the same, when, in what situation they can come at the same point? Intersection. When the pedestrians are doing what? They are always walking. They are crossing. Okay, so because of the crossing considerations, they become an important thing for us as well, because during these crossings you can have dangerous accidents. Okay, and these crossings do not only happen at intersections, especially like in the campus. If you are walking around within the campus, you don't wait to go to the intersection, right? You don't walk to the intersection to cross the road. You don't do this. You don't do this even in front of your house, like in the local streets. You will not cross the street. Look, let me go to the intersection, then from there I will cross. Okay, like 90% of the roads which you are allowed to cross, you don't walk to the intersection. Okay, 90% of the roads which are allowed to cross, these are obviously minor roads, secondary roads. Okay, major roads you are not allowed to cross. Then they have to go to the intersection. Okay, but those major roads are very few. Okay, so most of the roads on which you are allowed to cross, you cross from the mid block. Okay, they got the mid block meaning the segment. So for this they become very important consideration, that then we need their data as well. So later on you will see when we are doing the traffic analysis, we also put some factors about pedestrians as well within the analysis, within the equations. There are factors for pedestrians. In some cases we may have to do interview studies, and interview studies, I mentioned it yesterday as well, you will see it in the lecture, that interview studies are always related to finding out the behavior. Okay, so for example, a person is crossing from this location. Why you are crossing from this location? Okay, so I cannot know it until I ask that person. Okay, so anything related to the behavior of the driver, why are you crossing at this time, what is the purpose of your trip, from where you are coming, okay, and why are you walking, things like this. So to get this sort of information, which is about the behavior, attitude of the pedestrians, you have to do some you may have to do some interview studies as well. Then some studies are done for calibration purposes. You see some equation on the board, right? Huh? Now you see this equation between V and D. What is V? Flow or volume? Okay, fine. But it's small v, so we call it flow rate. Okay. But volume is also V, but capital. And what is B? Density. Where did you see this equation? Not very big. Huh? In the last topic, right? In the traffic flow topic, right? We derived this equation, right?
Yeah.
So the derivation started from where? From the graph. Okay. So these derivations are called as calibration. Deriving an equation, looking from the relationship of the data, is called calibration. Okay. So I showed you some graphs, right? For flow, density, flow, speed, and density, speed. I showed you some graphs. Okay. Some of the graphs were curves, some of them were straight line. Now you already know the relationship, right? This one is to be a straight line, this one should be a second degree curve. I already know the relationship from the data. But now I will use the data to calibrate the equation. Calibration means what? What should be the coefficients basically? Calibration means coefficients. Finding out the coefficients. These factors 65 and 0.59 and 110 and this. Okay, finding out these coefficients is known as calibration. In our terms, we call it deriving an equation, right? So that graph came from the data. So until unless you know the relationship, you cannot calibrate the equation. If you don't know the equation should be second degree or linear or third degree or exponential, you cannot derive, right? I need to tell you this equation will be a second degree equation. Then you start the derivation. Okay. So then we have observational studies. I called them yesterday as follow-up studies. Observational or follow-up. Okay. There's another name for it, which we will look at in the other topics. But follow-up or observational means the same thing. Okay. And it is done to follow up on the improvement you have made on the road. So you detected a problem on the road. There was too much traffic jam, too many accidents, any problem. To avoid that, you made an improvement of the road, on the road. Maybe you put a speed hump, maybe you increased a lane, maybe you change the signal timing. After making the improvement, you have to do a follow-up. That follow-up is known as observational study. So observational study, you go and see, did the improvement make any effect on traffic? Are we still having the same number of accidents which we were having before? Are we still having the congestion in the peak hour, the same type of congestion you were having before? Okay, so this type of study is known as a follow-up study. Okay, what are the methodologies we can adopt for collecting traffic data? I mentioned some of them, but not in this manner yesterday as well. You will see it in the lecture. So there are three types of methodologies to collect traffic data. Three approaches to collect traffic data. You can collect it manually, you can collect it using semi-automated methodologies or semi-automated techniques, or you can do it using fully automated studies. Okay, so manual, semi-automated, fully automated. Okay, let's start with manual studies. Manual meaning, who is collecting the data? The engineer. Huh? Sorry? The observer. Okay, thank God you didn't say a man. Manual means a man, so women cannot. Okay, so but what does it mean? The observer is required on the site to collect and record the data. If you take the observer out of it, your data will not be either collected or recorded. Okay, so having observer throughout the study on the site is important in all manual studies. Got it? Clear? Now, how long can we do it like this? Having an observer on the site who is constantly working to collect the data. How long can we do it? Less than 24 hours because it is written. Sure. Right? What's your name? Zara. Zara can do it for 23 hours.
No.
Right?
The working time.
I'll make you do it. Yeah.
The working time and after the
You
weekend.
got working time?
And from
Strictly
morning,
professional, huh?
from morning until
From morning until, don't call me before 9, don't call me after 5. And don't call me on the weekends. My phone is silent, my phone is off. Right? This is very good. This is how you should be. But you cannot be like this once you are employed. Okay. Say whatever you want right now. And that 23 hours can be real. Seriously. Seriously. Our friends who were on the side, not for data collection, we are very merciful. Traffic people are not. They are not rude. They are not cruel. Yeah. You go to construction site, 24 hours, 48 hours, 72 hours, whatever work is going on, you are not to leave until that work is finished. You cannot say, stop completing, I have to go to sleep. Sleep under the concrete. Okay, coming back to the question. Think about yourself. How long can you do it? How long can you do it? You meaning you. 1 hour. 4 hours. See, so he can do it for 4 groups. Right? He will do it for once for his group and 3 other groups can pay him for that. And I will take apart from it. Okay, but the point is manual studies cannot be long. Agreed? Manual studies cannot be long. Okay? Now, how long can they be? 24 hours or less than 24 hours, but it doesn't mean the same group of people. They will do it in shifts. Okay, and these shifts can be 4 hours. Okay, in no way 1 hour. Okay, 4 hours, 6 hours. Okay, so then the shift will change and some other people will come, but obviously they are still doing it manually, so we'll call them manually. Okay, so total duration, we don't prefer it to go longer than 24 hours even in shifts. Okay, because they have then more chances of errors. So if you keep it doing it for longer time, the errors accumulate. Okay, the error you were doing in 1 hour, you will do it 4 times in 4 hours, right? Okay, and so on. So because to control the amount of error, we don't do the study more than 24 hours, but even for 24 hours or less than 24 hours, you can have shifts. Okay, what type of studies we can do manually? We can do traffic counting. You did it for your term projects, right? Right now you have done it for 15 minutes. Later on you will do it for 1 hour. But counting is very easy, right? No? Okay. Speed or travel time. Okay, both are related, right? I have said it already a couple of times. Speed and travel time are related. When you know the travel time, you can calculate the speed. Okay, so these studies can be done manually. Maybe some of you have done the speed study using time for your term projects. Okay, maybe. I don't know. But you can do it, right? You can have a stopwatch for measuring the travel time. Once you know the travel time, you can find out the speed. Observational studies. I call them what else? Observational studies? Follow-up. Now the thing with follow-up study is, it's very focused. Because I already made a change, right? So I already know what to have. Why I am doing this. Okay? What is the thing I am looking for? So I change the signal timing. And my purpose was to have more flow from this direction. So you already know what you did and what it is supposed to have and when it is supposed to have. So observation studies are by nature very simple and short. If you can see the change in 10 minutes, okay, it's fine. Because I already knew that this thing should happen, right? I am looking for something expected. Okay? Like when you guys came, you were expecting that class should be closed, right? Huh? The door is closed. You all go home, right? Very simple and very short. So, this is observation study. By nature they are short and simple because you know what to expect. Okay. Then we have delay studies, intersection delay studies. Delay we will study it later on as well. Delay studies are normally done at intersections. Okay. Or at, let me rephrase it. For intersections, we always do a delay study. For intersections, we always do a delay study. Got it? Okay. Why we do it manually? Because intersection means it's one point. Okay. And delay, you want delay in which time? 24 hours? You want delay for which time? Peak hour. So there are 2-3 hours of the day, right? So it's by nature it's very short, and it's for a location. Another thing which you will see in all these points, which I mentioned for intersection and observation study, that they are for a specific number of locations. You cannot do manual study for the entire city. It will take a lot of time and a lot of people. Everybody will get a job. We don't want this. Okay? Entire city means what? Thousands of segments and intersections. At each location you will need a lot of people. So manual studies are short in time, and in terms of locations, again very few locations, for few locations. Got it? So in the first couple of points is already mentioned. Number of locations and this. Observational study is obviously the location on which you made the change. An intersection, again a particular location. Okay, so manual studies for a specific location and for short timings. Manual counting. For manual counting you can use hand counters. I showed it yesterday as well. It's in the previous slides. So this is a hand counter. Okay, so it's a very portable device, very light, and you can just keep it in your hand and you can just keep on counting. Okay, some of the students started using the counter which we use for cricket. We are standing on the side of the road and counting cards, and people are thinking you are an angel. You are saying Allah Akbar, something like this. Okay, but these are the counters which they use. Okay, so the counter, then you don't have to take a record on the paper. Once you finish the study, you can take it with you and you can record. Okay, and there are some apps available for as well for counting. You can download them in your phone or tablets and you can do the counting as well. Some of the apps are for counting on the roads, counting cars. Some of those apps are also available. Okay. Now the problem is when we are doing the counting, we count for how many minutes? 15? 15? Why did you do it? You said 15, right? Right. What? For the project. If we are not doing the project, then 15 minutes, because 15 minutes taken for peak hour factor. Okay. If we are not doing it 15 minutes, then maybe 1 hour. We use hourly work, right? So what will happen after 1 hour? Your study is 4 hours. So either you are taking count every 15 minutes, or maybe after every 1 hour. But what will you do after 1 hour? You have to put that value somewhere, right? And start from 0 again. If you are using a counter like this, the one shown in the picture, so right now you will see the value which it is showing right now. You will write it somewhere and put the counter to 0, right? And start again. If you are doing it on paper, again you have to mark that value. This is the end of 15 minutes. Now I will start counting again. Okay. So you have to reset your count. Now when you are putting the counter to 0 and you are writing the value, what will happen with the vehicles? Will they stop for you? Let this man count or this girl count? No, they will not stop. Okay? You will miss somewhere. Right? You will miss somewhere. So to incorporate this, we put within the counting systematic and what's the other word? Yeah, uniform and systematic breaks. We give the counting person, the observer, uniform and systematic breaks. Okay, so before he starts counting, we tell him that he will count for these many minutes, then he will have this much break, and then he will count again. So in the break, he can do all these things: resetting the counter, writing the value, drinking water, taking selfies, and so on. Okay, everything in the break. But the point is, the break is not up to the person who is counting. Okay, he cannot shift it. So you tell him count for 10 minutes and then take a 5 minutes break. And he says no, I will count for half an hour and then I will take a 5 minutes. No, he has to go according to the plan. If he doesn't follow the plan, then you don't know what to do with the values, because you don't know the value was taken for how many minutes. Maybe in the first half hour he didn't take the break, and after 1 hour he was taking break after every 5 minutes. Okay, so we cannot let this happen. We have to put an observer on the observer then. See when he was taking the break. We cannot do this. Okay, so you tell him the counting period and the break period, and this is uniform and systematic. Okay, so it is basically constant. The counting is constant, the break is constant. He cannot change it, and you will give it to him at the start. Okay. Now this this break period can be included in two ways. You can have a break within the counting period, or you can have alternative break and counting period. Two types of breaks: break within the counting period or alternate break and counting. Okay, what do we mean? For example, the counting period is 15 minutes. So within 15 minutes, you tell him this is your break period. Okay, the next count will start after 15 minutes. Within this 15 minutes, you may tell him, okay, 2 minutes is your break. Okay, so he is actually counting for how many minutes? If you give a 2 minute break, then he is counting for how many minutes? 13 minutes. Okay, this is one of the approaches. The other approach is you tell him alternate break and counting. So 15 minutes counting, break is 15 minutes. Got it? Yes. So break within the counting period, he will count more, less break. Alternate break and counting, same period of counting, same period of break, and so on. Clear? Okay. Now, what is the purpose of having it systematic and uniform? Once he gives you the value, I will show you in the example as well. So the observer comes from the field and he tells you these are my values. According to the plan of breaks, you can calculate the missing numbers. Okay, if there was no plan, there is no calculation. Okay, so for example, if you took the first approach, break within the counting period. Okay, so the counting period is, let's suppose, y number of minutes. Okay, so you ask them to count for y number of minutes. The next count will start after y number of minutes. Y can be 10, 15, whatever. And the number of the break was within this y number of minutes. Okay, so he actually counted for x number of minutes. Okay, so x plus break equals to y. Okay, got it? So an example is given. Let's say the total period was 5 minutes. So every count starts after 5 minutes. Within 5 minutes, you told him you have a 1 minute break. So he's counting for how many minutes? So how much is y? 5. How much is x? 4. Okay. So if he gives you a value, he is giving you a value for how many minutes? 4. How do you convert it to 5 minutes? So for example, he gave you a value 100. 100 in 4 minutes. So how many in 5 minutes? 100 over 4 times 5. This is what is written here. This is the count he gave you. Divide by number of minutes he counted. Multiply by the number of minutes you want. Clear? So that y and x is fixed. Y and x is fixed. So on all the values I have applied the same formula, right? All values are for 4 minutes and all values are converted to 5 minutes. What no? I am telling you yes.
I mean, it so depends on the question. Maybe they consider fun.
We are in the exam mode, huh? We are in the exam mode. Somebody told you, you go to the field, count for 5 minutes interval, and within every 5 minutes take 1 minute break. Okay, now you give him the values. He's supposed to, from your values, he's supposed to calculate the 5 minutes value.
Yeah.
So he will do what? With every value he will do the same, right?
Yeah.
Because every value took 4 minutes and he wants 5 minutes.
But
So
if-
with every value he will do the same.
Yeah, but if they tell me like 10 minutes.
That's a different
Yeah. I thought
case.
he's saying for always.
Not all. All numbers are examples. All numbers are examples. Focus on the approach. What is the approach? You have a counting period and within that you have a break period. Okay? So whenever this is happening, you have y which you know. You have x which you know. And the y and x for each case is fixed. For each study, y and x is fixed. Okay? So if you did the counting for 24 hours in this, I know what to do with all the hundreds of values you give me. Got it? This is why we make it systematic and uniform. If you are taking the other approach, what was the other approach for break?
Count 5 minutes and take 5 minutes.
Yeah, alternative, right? Now what to do with this? Now, in this case, so you will count for 5 minutes, take a break for 5 minutes, and count again for 5 minutes, right? I want the middle value, right? In which he was resting. So I do what? I do the average. I have the value before, I have the value after, I do the average, I will get the value of the break. Okay. This is what is written here. Value before, value after, take the average, you get the value in the middle. Clear? Any questions? Okay. This is a question which includes both types of calculation which I just showed you. Taking the average as well as doing y upon x. It includes both of them. Okay? Now don't do this for your project. Okay, I'm about to explain you what they did. Don't do it for your project. No breaks for your project. 1 hour, you are healthy enough. Okay, Alhamdulillah. Say Alhamdulillah. Okay. You can go there for 1 hour, just count. Okay. Take 15 minutes intervals, calculate the peak hour factor and have 1 hour. Okay. Don't make your life difficult. Okay. And my easy. Make a mistake, my life becomes easy. Okay. So what did they do? They had a highway with 4 lanes, 2 in each direction. 4 lanes, 2 in each direction. Okay. They had 2 observers. How many observers? 2. How many lanes? 4. What did they do? They said, okay, we'll put 1 observer in each lane. Then they have 2 observers short, right? 2 observers, 4 lanes. 1 observer on each lane. Why 1 observer on each lane? Because it's more accurate. Because it is more accurate. Because in 1 lane he will see 1 car at a time. Cars will go behind each other, right? Make a line. So 1 lane is easier to count, less chance of errors. If the same observer is counting multiple lanes, he may count from one lane and miss the other lane at a time. So there are more chances of error. Okay? So one lane is easier and more accurate for the observer. This is what they want to do. But then they are short. Okay? So what did they do? They told the observer, okay, you count for 12 minutes in one lane. Then you take a 3-minute break. Then next count, next 12 minutes, other lane. So one observer is counting 2 lanes, but one at a time. One at a time. Okay? How much is his counting period? 12 minutes. How much is his break period? 3 minutes. And he is doing alternate what? Alternate lanes. He is alternating between lanes, right? So 12 minutes in one lane, 3-minute break, then 12 minutes in the other. Got it? There. So I have to do both calculations because there is a 3-minute break, and for every lane there is an alternate count, right? You can see it over here as well. Okay, every count is 12 minutes, and after every count I have a break as well. Not a break, a gap, because he is counting on the other side, right? So it's not a break, but there is a alternate gap, so the calculation will remain the same. Okay, I will do both types of calculations. Okay, the first type I will do is convert these values to 15 minutes. Okay, I need to convert all these values to 15 minutes. So what would I do with all these values? Tell me.
360 times.
Yes, 15 over 12. Okay, every value divide by 12 because it is for okay, so I have the time here, I have the eastbound lane 1, westbound lane, eastbound lane 2, westbound lane 1, westbound lane 2. Okay, so first of all I will convert all counts to 15 minutes. So every value divide by 12 because taken for 12 minutes, multiply by 15 because it is, you want it for 15 minutes. Okay, so start doing it. Okay, so 350 becomes what? Huh? 350 becomes 450. Okay. So what did we do? 350 divide by 12, then multiply by 15. Sorry?
4, 3.
Next. Okay, 370 becomes what? 462. Next. 431. Okay. Next. Okay. Lane 2. 450. 475. 462. 4.
356.25. 375. 350.
3.
387.5. 412.5.
Okay. Any problem till now? All counts for 12 minutes. I converted to 15 minutes. Very easy. Now the all lanes have gaps, right? I need to fill the gaps. What did we say? We will fill the gap by taking average. Okay. So give me the gaps. Now you have gap at the top, at the bottom as well. You cannot take an average here. Okay. For the time being, just leave them. Just give me the gaps which are in between the two values. So I will take the average of 438 and 462, which is how much? 450. Okay, next. Next. 68. 68. Okay. $365. Four. Okay, now what about the first value? For the first value, obviously I cannot take the average because I don't have the value on the other side. Okay, average only comes when you have both values. Okay, so what we will do is you can call it extrapolation. It's a sort of an extrapolation. You know interpolation, right? What we just did is an interpolation. You have two values. You can calculate the value. Remember, interpolation. For extrapolation, we will take the difference of the next two values. and apply it to the immediate value. Okay, taking the difference of the next two values. What are the next two values? 438 and 450, right? So you'll take the difference, and whatever the difference is, you apply to the immediate value. What is the immediate value? 438. Okay, so you will do it like this: 438 minus 450 plus 438, which gives you how much? 4. 450. How?
12, the difference, plus 438.
The difference is negative, right? Okay, same thing will be done for the last value. You will take the difference of 425 and 443 and apply it to the immediate value. How much is this? Again, it will be negative. If the value has to increase, the difference will be positive. Okay, so you just apply it as it is. 425 minus 443, it will come out to be negative, plus 425. Do it. Do it exactly as I have written,
Next value,
minus the next value. 438 minus 450 is the answer negative. Now you do plus. Just do plus. Don't do 438 plus 12. Whatever answer you have, just. How much is it? Okay, how much is this? 347. And how much is this last one? Any problem? Not this? $388 minus 19, huh? Any problem? The calculations are clear? Everything is clear? Okay. So this was first part of the question. Second part of the question is, let me see. We did the first part. Find out continuous 15-minute count. Now all these values are 15 minutes, right? And no gap. There's no gap now. So we did the first part. Second part is find out peak hour volume, and peak hour factor. For that, for each direction and for the highway or freeway. Meaning you do it for each direction separately and then combine them and do it again. Got it? Each direction has 2 lanes, right? So do the peak hour volume, peak hour factor for each direction, for eastbound and then westbound. Done? Then combine them and then do it again. Peak hour volume, peak hour factor, and peak hour itself. Okay? To do this, they are asking for what? Do it for each direction, right? So first of all, I should combine the values for each direction, right? And they are saying what? Then do it for the total, for the freeway. So I need to combine the values for the full freeway as well. Okay, so each direction meaning combine values of each 2 lanes, and the total means combined values of all 4 lanes. Clear? Okay, so I'll take it out from here. Whatever calculations we are doing on these values. Okay, so this is the total of eastbound, this is the total of westbound, and this is the total of the freeway. They are calling it a freeway. Okay, freeway meaning both directions. Freeway meaning what? Both directions. Okay, give me the total. So this will be 450 plus 426. Okay, next one, 462 plus 438. 475 plus 450. 468 plus 462. 932? Huh? How much?
No, 1,000.
1030. I thought you were telling me time, 1030.
909.
Sorry?
909.
Huh? 87? 5. 849.
51.
Huh?
841.
41. Next, 807. Westbound. Wrong. How much? 930. Okay. Tell me the first value.
731.
Okay, this one. Huh? 777. Very good number. Huh? 793.
787.
This one. 726. Last one. 694. Okay, now what you will do for the freeway? Take east and west total and add them. Okay, so 876 plus 735. How much? 1611. Next. So 756 plus 900. 925 plus 777. Huh? 1702.
1723.
1723.
1697.
Okay. 1632. 1567. 1501. Okay. Any questions? Clear? Okay. We will continue with this problem. It's not finished yet. Okay. So we'll continue.